Imagine swallowing a liquid that doesn't just poison your blood, but literally cooks your organs from the inside out in milliseconds.
Yeah, it's a terrifying thought.
It really is. Today, we are looking at what happens when the safe, controlled boundaries of chemistry are just completely stripped away. Welcome to the deep dive.
Glad to be here.
So, we're diving into a grim but honestly fascinating corner of medical jurisprudence. We're looking at what happens when chemistry becomes a weapon.
Right, whether that's by accidental ingestion or far more terrifyingly malicious intent.
Exactly. And it's a huge shift in perspective for you, the listener. You're taking something foundational to modern life, like industrial acids or heavy-duty cleaning bases, and exploring how the human body reacts when those substances go from tools of creation to, well, tools of absolute destruction.
And very localized destruction at that.
Right. So to understand this, we are unpacking the clinical reality of corrosive poisons. We're talking mineral acids and strong alkalis.
The really heavy stuff.
Yeah. Our mission today is to give you a comprehensive understanding of the biology here. What these substances actually do to human tissue, the completely counterintuitive medical treatments required to save a life, and the dark legal evolution surrounding how these chemicals are weaponized out in the real world. Okay, let's unpack this.
Well, when you delve into the clinical guidelines for treating this kind of chemical trauma, you quickly realize it's basically a masterclass in fighting against the body's natural instincts.
I know.
Medical professionals are forced to think on their feet, to mitigate this massive damage that unfolds in literally mere seconds.
Yeah, the timeline here is what makes it so uniquely terrifying. But I think before we get to the wide-scale symptoms that you would experience as a patient, we need to zoom way, way in.
At the cellular level.
Exactly. We need to understand the microscopic action. Like, how are these corrosives actually working down there? Because unlike venom from a snake bite or a barbiturate overdose, a corrosive doesn't need to travel to your brain or your heart to kill you, right?
No, not at all.
The damage is strictly local.
Precisely. That local action is the defining characteristic of a corrosive poison. When it comes into contact with the tissues of the alimentary tract or the respiratory system, it doesn't wait around to be absorbed into the bloodstream.
It just starts destroying immediately.
The millisecond it touches the tissue, there is absolutely no remote systemic action.
So there's no waiting for the liver to process it or anything. The trauma happens right there on the surface of the throat or the stomach.
Right.
And clinical pathology actually breaks this local trauma down into this unholy trinity of chemical action.
Yeah, the three major steps.
First, there is the aggressive extraction of water from the tissues.
Wow.
Second, the coagulation of cellular proteins. And third, the conversion of hemoglobin into a substance called hematin.
Which is devastating.
It is. And I was trying to visualize this trio of destruction, and I think the best analogy is like cracking a raw egg onto a scorching hot frying pan.
Oh, that's a visceral image.
Right. The clear protein instantly turns white and solidifies. That's the coagulation of the cellular proteins. And it sizzles as all the moisture is aggressively boiled away, which is the extraction of water.
That's spot on.
So the tissue is literally being chemically cooked and dehydrated on contact.
What's fascinating here is that your frying pan analogy perfectly captures the sheer violence of the reaction. The tissue isn't just being irritated,
Right.
Its fundamental molecular structure is being irreversibly altered. The cells are instantly drained of water, their proteins are scrambled, and the blood itself is chemically changed.
That hemoglobin conversion you mentioned.
Exactly. Hemoglobin, which carries oxygen and gives blood its bright red color, is converted into hematin. And hematin is this dark brown or black compound.
Wow.
That is why the resulting dead tissue, the necrotic slough, looks so horrifying. It's starved of oxygen and completely chemically burnt.
Jeez. And it's the sheer overwhelming intensity of this local destruction that triggers the one and only systemic effect, right? Primary shock.
Yes. The body's nervous system is essentially overwhelmed by the sudden catastrophic pain and massive tissue loss.
This just shorts out.
Basically. The alarm bells ring so loudly that blood vessels dilate rapidly all over the body, blood pressure plummets, and the entire circulatory system can just collapse.
And that's primary shock.
Right. And it is frequently fatal before the chemical itself is even finished burning.
That is, wow. And knowing how it destroys tissue on a cellular level really explains what that destruction actually looks and feels like for the patient.
Because there's no incubation period.
None. The moment the substance is swallowed, there is an intense burning sensation in the mouth, the throat, the esophagus, the stomach. You would experience intense thirst, but swallowing becomes incredibly difficult, if not impossible.
due to the rapid swelling of the throat.
Right. And the visceral response is immediate, isn't it?
Oh, absolutely. The patient will experience continuous retching and the vomiting of what is clinically described as shreddy, blood-stained material.
Shreddy. That is such a grim word.
It is. The chemical is actively stripping the mucosal lining of the digestive tract, and the body's defensive reflex is desperately trying to expel it.
And depending on what was ingested, that vomit will be highly acidic or alkaline. And the physical signs on the outside, they just mirror the chaos inside. Doctors will look for signs of corrosion around the mouth and lips.
And the tongue changes too.
Yeah, the tongue itself physically changes. It might be massively swollen and beefy or completely shriveled and pale. But here is a clinical detail that completely surprised me.
Oh.
Yeah. Depending on whether you swallow an acid or an alkali, the symptoms in the lower digestive tract drastically diverge.
Right, the split symptoms.
Yeah. If someone ingests a corrosive acid, their bowels tend to be constipated and their urine becomes scanty. But if they ingest a strong alkali, they experience severe cramping, which is called tenesmus, and frequent stools mixed with blood and mucus.
It's a very clear diagnostic split.
So why the drastic difference in the lower digestive tract? Why does acid cause constipation while alkalis cause frequency in mucus? Like, what is the biological mechanism driving that split?
It really comes down to how these specific chemical families interact with biological material. While both are highly corrosive, they destroy tissue in fundamentally different ways.
Okay.
So mineral acids cause extreme fluid loss and essentially a drying, constricting effect on the upper GI tract.
Which ties directly back to the frying pan analogy.
Exactly, that massive extraction of water and protein coagulation. The body is rapidly losing fluid to the chemical reaction itself, combined with the vomiting.
So they're just completely dried out.
Yes, it throws the patient into a state of profound dehydration.
Right.
That halts kidney function, leading to the scanty urine, and it pulls all moisture from the bowels, causing the constipation.
So the acid essentially freeze-dries the system from the inside. But what about the alkalis?
Alkalis, like caustic soda, cause what is known as liquefactive necrosis. They don't dry the tissue out, they turn it into a soapy liquid mush.
Ugh, that sounds terrible.
It causes a deep, penetrating, sloughing type of tissue destruction. The mucosal lining doesn't just dry up, it aggressively sheds.
Right, so it's not staying put.
No. And this provokes a massive sweeping inflammatory response further down the digestive tract, which is why you see frequent stools heavily mixed with blood and shedding mucus. The body is desperately trying to flush out this penetrating, slippery destruction.
Wow. And as if the digestive tract isn't enough, we have to look at the respiratory dangers.
Those are often the most immediate threat.
Right. If the substance is a volatile, fuming fluid like nitric acid, inhaling those fumes, or even accidentally splashing the liquid into the airway during the frantic choking and vomiting, it's catastrophic.
The swelling is instantaneous.
Yeah, the glottis, the opening between the vocal cords, can become so swollen from edema that it completely blocks the airway, leading to suffocation.
And through all of this, the cardiovascular shock, the pale, anxious face, the rapid, feeble pulse, the suffocating airway, the most chilling clinical note is that consciousness is usually retained until the very end.
Which is just a nightmare.
The mind remains painfully, acutely aware of the body's destruction.
It's horrific. And death can come quickly from that primary shock or from suffocation. Or, in severe cases, the stomach wall can become completely perforated, dumping corrosive acids straight into the abdominal cavity.
Which is a whole other level of trauma.
But let's say a patient survives that initial terrifying window. The danger is far from over, right?
Not at all. If the quantity swallowed was smaller, or a medical intervention was incredibly fast, death might be delayed by days. And one of the primary causes of delayed death is hypostatic pneumonia.
Okay, this is one of those clinical terms that needs breaking down. Why would swallowing acid give you a lung infection days later?
It is a domino effect. The patient has survived the burn, but their body has been ravaged by severe shock. They are bedridden in excruciating pain, and their breathing is incredibly shallow because any movement of the chest cavity just hurts too much.
Right, they can't take a deep breath.
Exactly. Because they aren't taking deep breaths or moving around, fluids begin to pool in the lowest parts of the lungs simply due to gravity.
Oh, I see.
And that pooled fluid becomes a perfect, stagnant breeding ground for bacteria. That is hypostatic pneumonia. And for a patient already fighting for their life, it is often a fatal complication.
But even if they beat the pneumonia and fully recover from the immediate poisoning, the delayed effects are devastating.
The strictures.
Yes, The massive scarring in the esophagus leads to a stricture. As that scar tissue heals, it forcefully contracts, severely narrowing the throat over months or even years,
A person physically loses the ability to swallow food.
leading to severe emaciation and malnutrition. So a single moment of ingestion creates literally a lifetime of physical consequence.
Which brings us to the crucial, high-stakes environment of the emergency room. Knowing the catastrophic local damage happening inside the body, medical professionals have to follow a highly counterintuitive set of protocols, the do not do list.
Right. And here's where it gets really interesting. If you are an ER doctor, or even just a bystander, your absolute first instinct when someone swallows poison is to get it out.
Of course it is.
You want to pump the stomach, or give them a drug to make them throw up. But clinical guidelines state that stomach washes and emetics are strictly contraindicated.
Do not do it.
Exactly. Inducing vomiting in this specific scenario would be like swinging a wrecking ball down a delicate hallway, realizing it was a mistake, and then swinging that exact same wrecking ball back up the same hallway. You're just doubling the damage.
That wrecking ball analogy perfectly illustrates the mechanical vulnerability of the tissue. The esophagus has already been necrotized on the way down. Forcing the stomach to violently contract and push that corrosive fluid back up will almost certainly result in a rupture.
You're just tearing the throat wide open.
Yes. Now, there is one narrow exception. A soft Levine stomach tube can be passed, but only with extreme care, and only within about an hour of ingestion.
Just to gently siphon it out.
Exactly. The goal is to siphon the poison out to prevent those serious caustic burns from turning into the strictures we just discussed.
But if we can't safely pump it out, what about neutralizing it? Like if I swallow a strong acid, simple chemistry class logic says I should swallow a strong base, like an alkaline carbonate, to cancel it out.
Basic chemistry logic would suggest that yes. But human biology dictates otherwise. Medical guidelines explicitly warn that if an acid has been swallowed, alkaline carbonates are strictly contraindicated.
Wait, really? But why? You're still neutralizing the acid, aren't you?
You are neutralizing it, but you have to look at the byproducts of that specific chemical reaction. When you mix an alkaline carbonate with a mineral acid, it produces a massive amount of carbon dioxide gas.
Oh.
Inside a beaker, it just bubbles over. Inside a closed, severely damaged human stomach, that gas expands rapidly. The stomach inflates like a balloon.
And the stomach wall is already weakened.
Exactly. It's been thinned out by the acid. So that sudden pneumatic pressure will blow a hole right through it. You basically trade a chemical burn for a catastrophic internal explosion.
Wow. Okay, so strong carbonates are out. Instead, you treat acid poisoning with weak alkalis, or better yet, just massive quantities of water, milk, or egg albumin to safely dilute the acid and coat the stomach lining.
Yes, gentle dilution.
But what if the situation is reversed? What if someone swallows a strong alkali, like caustic soda? The guidelines say you neutralize it with a weak acid, like vinegar. Why doesn't the vinegar cause the stomach to explode like the carbonate did?
Comes down to the specific chemical reaction again. When you mix a strong alkali with a weak acid like vinegar, which is basically dilute acetic acid, the reaction produces a harmless salt and water.
Ah, so no gas.
Right. There is no carbon dioxide gas generated. It safely neutralizes the alkali without turning the stomach into a pressure bomb.
That makes so much sense. And the supportive care required alongside this is immense. Doctors are injecting morphine to manage the excruciating pain. They give the patient ice to suck on, which relieves the intense thirst without filling the stomach with heavy liquid.
They'll have intravenous fluids pumping too.
Right, to combat the massive fluid loss from dehydration, and they also administer corticosteroids.
Yes, the corticosteroids serve a dual purpose here. They help manage the immediate systemic shock, but more importantly, they're an attempt to prevent that delayed esophageal stricture.
How do they do that?
Well, corticosteroids forcefully suppress the immune system's inflammatory response. By reducing the inflammation in the throat, doctors are trying to stop the body from laying down the dense, contracting scar tissue that will eventually choke off the esophagus.
It is just a massive, desperate medical intervention. And if the glottis is swelling shut, they have to perform a tracheostomy, cutting a hole directly into the windpipe so the patient doesn't suffocate.
And sadly, if these interventions fail, the post-mortem forensic findings confirm the violence of the process. Pathologists find signs of corrosion wherever the poison made contact.
Externally and internally.
Yes, externally the lips are burned,
Yeah.
and there are distinct trickle marks running from the mouth down the chin and neck. Internally, the destruction varies from localized necrotic patches to extensive areas of the stomach being completely eaten away.
And because swallowing this stuff is so immediately agonizing and leaves such undeniable forensic evidence, it's rarely used for suicide or covert homicide anymore.
It's just too painful and too obvious.
Right. If you want to poison someone quietly, you don't use sulfuric acid. But this brings us to a really devastating shift in human behavior. Perpetrators looking to inflict prolonged, visible suffering have taken these chemicals and turned them outward.
Yes, the crime of vitriolage.
Exactly. The horrific internal damage we've been analyzing is now deliberately inflicted on the outside of the body.
Vitriolage is the act of throwing corrosive fluid on a person with malicious intent. The explicit goal isn't necessarily to kill. It is usually driven by jealousy, hatred, or vengeance.
With the intent to destroy vision or cause severe permanent facial disfigurement.
Right.
The term vitriolage comes from the historical name for sulfuric acid, which was oil of vitriol. But the malice doesn't stop with just one chemical. Perpetrators use nitric acid, carbolic acid, caustic soda, caustic potash, iodine. And then there is one substance on the list that completely threw me.
The marking nut juice.
Yes,
Yep.
marking nut juice. So what does this all mean? Look at that list. We are talking about pure, refined, industrial laboratory chemicals existing right alongside the juice of a specific nut. It really highlights the sheer malicious improvisation of human beings.
It does.
If someone wants to destroy another person's life, they will weaponize whatever is in their environment.
If we connect this to the bigger picture, you are observing a deeply disturbing truth about human intent. The weapon adapts to the environment, but the desire to permanently mark and ruin a victim remains constant.
It's chilling.
The marking net, or semicarpus anacardium, has historically been used by washermen in certain regions to mark laundry because its dark resin leaves a stain that never washes out.
Okay.
But that same resin is a vicious, vesicant, and corrosive. Weaponizing a mundane laundry tool shows a chilling level of premeditation.
And forensically, the evidence left behind by these external attacks is undeniable. Forensic experts look for very specific markers to differentiate a chemical burn from a thermal burn, like from fire or boiling water.
There are those classic trickle marks where the fluid ran down the skin following gravity.
Right. But the really distinct marker is the absence of vesiccation, meaning there are no blisters.
That lack of blistering is a crucial forensic key. When you touch a hot stove, your skin blisters because the heat damages the upper layers, and your body pumps fluid in to protect the tissue underneath.
But a chemical burn is different.
Completely. A corrosive chemical destroys the cellular structure so rapidly and aggressively that the body simply doesn't have time to form a protective fluid blister. The tissue is instantly necrotized. You also won't see the red line of demarcation around the wound that typically borders a thermal burn.
And then there's the staining. The chemical literally dyes the victim's skin and clothing. Sulfuric acid leaves deep brown or black stains, while nitric acid leaves yellow stains.
It acts as a permanent chemical record of the assault.
And the immediate emergency treatment for these external attacks requires massive urgent dilution. First responders have to wash away the corrosive with huge volumes of water and soap, or a dilute solution of sodium or potassium bicarbonate.
And later, medical staff might apply a thick paste of magnesium oxide to safely neutralize any remaining acid deep in the tissues.
Followed by aggressive antibiotic ointments for the raw, exposed flesh.
Yes.
And if the eyes are involved, which they so tragically often are because perpetrators specifically target the face, they have to be washed instantly with a massive amount of water, followed by irrigation with a 1% solution of sodium bicarbonate.
Then they instill a few drops of olive oil to soothe the tissue.
Along with eye drops containing antibiotics and steroids to try and save whatever vision is left. It is a desperate race against the clock.
And because these acid attacks have, historically, been on the increase in various parts of the world, the legal system has been forced into a major evolution to confront them.
Right. Legal systems historically tried to prosecute these attacks under general assault or grievous hurt laws, but a broken arm heals. A melted face does not.
The law simply lacked a framework for non-lethal, permanent, catastrophic disfigurement.
Exactly. That's why specific legal codes like sections 326A and 326B had to be written into existence.
It was a necessary, although tragic, legal evolution. These sections specifically define an acid attack as throwing or attempting to throw acid or any corrosive substance to cause scarring, disfigurement, disability, or grievous hurt.
The justice system had to create an entirely new category of crime to match the severity of the lifelong physical and psychological scars these chemicals inflict.
The punishments under these specific sections are severe, ranging from a minimum of 5 to 7 years all the way up to 10 years to life imprisonment.
But perhaps the most important legal shift is the financial aspect. The law mandates that hefty fines imposed on the attacker must be paid directly to the victim as compensation.
To cover their immense ongoing medical expenses.
Yeah.
This raises an important question about how we view clinical texts. We often look at medical jurisprudence as just a book of biology and legal definitions. But really, it is a mirror reflecting human history and human behavior.
That's a great point.
The way a textbook describes the cellulopathology of a chemical burn tells us about science. But the fact that a textbook has to dedicate entire chapters to the laws surrounding acid attacks, that tells us a great deal about the society we live in.
It really does. When we look at laws like sections 326A and 326B, we have to ask ourselves how much of modern medical jurisprudence is shaped purely by scientific discovery and how much is simply forced to evolve in response to the darkest corners of human creativity.
It's a sobering thought.
We've covered a tremendous amount of ground today, from the microscopic protein coagulation that chemically cooks tissue to the perilous timeline of primary shock.
And the treatments.
Yes, we explored the counterintuitive use of milk and vinegar in the ER, why you should never use a wrecking ball to clear a burned throat, and the tragic forensic reality of vitriolage. Next time you're reaching under your sink and see a warning label on a bright plastic bottle of household cleaner, think about the immense complex history that single label represents.
It's not just a safety tip.
No, it is a testament to the fragile boundary between chemistry as a tool of modern convenience and chemistry as a weapon. Thank you for joining us on this deep dive. Keep asking the hard questions, keep looking past the surface, and keep your curiosity sharp. We'll see you next time.